Hey guys, so at this point we have learned three methods to solving quadratic functions. Those methods are completing the square, factoring, and quadratic formula. So now which one should I use? That's a big question that comes up for us. So what I want us to talk about is a little trick, and this trick is called the discriminant. So the discriminant tells us whether the solutions of a quadratic are real or imaginary. We're going to talk about this in a few weeks. And how many roots a quadratic equation has. So some quadratics have 0 roots, some have 1, and some have 2. And remember, roots are where it crosses the x-axis. So notice the formula is b squared minus 4ac. And it is the same formula that comes from the underneath part of our quadratic formula. So check it out. Here's our quadratic formula. Here's the b squared minus 4ac. So this is going to help us determine which method you can use. So like I mentioned in class, you can always use quadratic formula and completing the square. Factoring, though, only works for specific questions. So if the discriminant, so if I plug in b squared minus 4ac and the discriminant equals 0 or a positive perfect square, so that would be something like 25, 49, all right, then you can use any of the three methods. So it doesn't matter which method you use. You can use quad formula, completing the square, or factoring. So basically just pick your favorite method and solve it, whichever one you're most comfortable with. But sometimes you can't factor, all right? So if you do the discriminant and you get a number that is not a perfect square, so 78, for example, then you cannot factor. So then your only two options are quad formula and completing the square. All right, again, if you don't want to use this trick, the quadratic formula and completing the square will work for every equation. So if you're comfortable with that, you can just do that. But if you prefer to factor, then you have to test it to see if it's even factorable. So let's look at this first example. Let's figure out our A, B, and C value. So our A in this case is 1. Our B is -4, and our C is -13. Remember, do not put the x's. So our discriminant is b squared minus 4ac. And now I'm just going to go ahead and replace. So b squared minus 4ac. So my b is -4. My next blank is my a value. That's 1. And lastly, my c value is -13. All right, so I plug it into the discriminant. I'm going to simplify that in my calculator. -4 squared minus 4 times 1 times -13. And I get the number 68. So is 68 a perfect square? No. So that means it is not factorable. So I prefer to use, I think completing the square. And that's how I'm going to solve this equation. All right. Before I solve, let's go ahead and try another example to see which method I can use. So here's another example. Let's figure out what's our A, B, and C. So our A is 2, B is -3, and C is -5. Our formula, b squared minus 4ac. Go ahead and plug in which one of these is correct. So negative 3 squared minus 4 times 2 times negative 5. That is typing it incorrectly. All right, I plug this into my calculator and I get 49. If you're not sure if something is a perfect square or not, take the square root. If you get a decimal, then it's not a perfect square. If you get a whole number, then it is a perfect square. So if I take the square root of this, I would get 7. So it is a perfect square. So I can factor. All right, so let's actually solve this one. I also want to show you, what if you didn't want to do that trick? What if you wanted to do something different? So let's say you thought, and don't write this down because I'm going to erase it in a second, but let's say you thought you could factor this one, and you tried to do the product sum table. You would see the product is negative 13 and the sum is negative 4. I'm never going to have, so the only things that multiply are 1 and 13. These are not going to give me negative 4. This would give me 12, and this would give me negative 12. So this doesn't work. So that's why, another reason why I have to use completing the square or the quadratic formula. All right, so that's the trick. Let's actually solve this just to have some review. So completing the square, I'm going to move my C term to the other side. I'm going to add my box. What goes in the box? B over 2. In this case, it is negative 2. All right. I bring down my x. I bring down my negative 2. And I'm going to simplify my right side. So 13, negative 2 squared is 4. So that equals to 17. Now we are solving, so at this point I need to isolate. So in order to isolate, I need to do the inverse of a square, which is a square root. So I get x minus 2 is equal to plus or minus the square root of 17. I'm going to move that over by adding, and I get x is equal to 2 plus or minus the square root of 17. Now we want to split this up because we want our two roots. So 2 plus square root of 17 and 2 minus square root of 17. Now if I check this in my calculator, I do get decimals. 2 plus square root of 17 is equal to 6.12. And 2 minus the square root of 17 is equal to negative 2.12. But you don't even have to do that. You can just leave it as this, which is probably, honestly, how you'll see it in multiple choice assessments. So just make sure you know either way. All right, so those are my two roots. That's where it crosses the x-axis. All right, let's see. I have another minute to go. Let me recap factoring. All right, so I take my first and my last, and I'm going to make my product sum table. So my product is negative 10x squared. What's my sum going to be? Negative 3x. So what numbers multiply to negative 10 and add up to negative 3? That would be negative 5x and positive 2. So I'm going to rewrite my original. I'm going to replace my middle term. So instead of negative 3, I'm using my magic pair. Negative 5x and positive 2. Everything else stays the same. And now this is what I'm going to use to factor. So 2x squared minus 5x plus 2x minus 5. All right, so if I look here, what is the GCF? My GCF for this is going to be 1x. If I check the GCF for the bottom, I can only take out a positive 1. Now, on my top, I can either do the GCF for my rows, or I can think about what do I need to multiply. So 1x times what gets me 2x squared? All I'm missing is a 2x. 1x times -5 would get me this -5x here. So these are my factors. So I'm going to write them. 2x minus 5. 1x plus 1. We have to set it equal to 0. We are almost done. I need to solve my mini equation. So when I solve this, I'm just going to get x is equal to -1. Remember, it's opposite, which is nice and easy. But in this case, I need to solve for x. It's a two-step equation. So I add 5 to both sides. 2x is equal to 5, and then I divide by 2, divide by 2. So x is equal to 5 over 2. And those are my two roots. All right, as always, if you have any questions, type them in at the end of the video.